Welcome to this lecture on this course Computer Aided Power System Analysis. We are now discussing the Newton-Raphson load flow in the polar coordinate. So, in the last lecture we have seen that for solving the power flow equations we do linearize those equations around the initial operating point, and after we do the linearization we get this matrix equation. We get this matrix equation. Now we will now look into all this quantities, all these vectors and matrices more closely. Now what is J1? J1, if we do recall, it is actually del P2 by del theta 2, then dot 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 del P2 by del theta n, then dot 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 del Pn by del theta 2 dot 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 del Pn by del theta n. So, this is written as in the language of the multivariable calculus, del p vector partial derivative of p vector with respect to the theta vector. Now, what would be the dimension here? Dimension would be, you see, P2 is actually varying from P2, P3 up to Pn. So, then therefore, there are n minus 1 rows, and theta 2 is also varying from theta 2, theta 3 to theta n. So, there would be n minus 1 columns. So, it would be n minus 1 row and n minus 1 column. What would be J2? J2 matrices del P2 by del Vm plus 1 dot 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 del P2 by del Vn. Then it is del Pn by del Vm plus 1 dot 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 del Pn by del Vn. So, again in the language of the multivariable calculus, we say that J2 matrix is nothing but the partial derivative of p vector with respect to v vector, and we have already defined what is p vector and what is v vector. Just to recall, theta vector is theta 2, theta 3, theta n transpose is n minus 1 cross 1. V vector is Vm plus 1, Vm plus 2 to Vn transpose. So, this is a n minus m cross 1 vector. Vector p is P2, P3, Pn. So, this is n minus 1 cross 1, and vector q is Qm plus 1, Qm plus 2, Qn transpose. So, this is also an n minus m cross 1. So, then therefore, now here what would be the dimension of this? So, dimension of this would be, there are how many rows? n rows P2 to Pn and how many columns? There are m plus 1 to n. So, n minus n columns. So, it is n minus 1. So, n minus 1 rows into n minus m column. What would be J3? J3 is del qm plus 1 by del theta 2 to dot 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 del q plus 1 by del theta n dot 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 del q n by del theta 2 del theta n. So, we call it as del q partial derivative of q vector with respect to theta vector. And what would be the dimension? Dimension would be how many rows? N minus m rows, and how many columns? N minus m, n minus 1. So, n minus m cross n minus 1. And J4, J4 would be del q m plus 1 by del v m plus 1 del v n del q n. So, it would be del q by del v vector and its dimension would be n minus m cross n minus m. Now, what is delta theta vector? Delta theta vector is delta theta 2, delta theta 3, delta theta n t. So, then therefore, it has got n minus 1 cross 1 vector. What is delta v vector? Delta v m plus 1, delta v m plus 2, delta v n t. So, it is n minus m cross 1. What is delta p vector? Delta p vector is, if you recall, it is P2 specified minus P2 calculated, rather I should write actually delta P2, delta P3 dot 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 delta Pn transpose. So, it has also got n minus 1 cross 1, where delta pi is pi specified minus pi calculated for all I is equal to 2 to n. So, then therefore, delta P2 is nothing but P2 specified minus P2 calculated, delta P3 is nothing but P3 specified minus P3 calculated, and dot 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 similarly delta Pn is nothing but Pn specified minus Pn calculated. And lastly, delta q vector is actually delta q m plus 1, delta q m plus 2, t transpose. So, it is n minus m cross 1, and where delta q I is equal to q I specified minus q I calculated for all I is equal to m plus 1 to n. So, then therefore, we again write down to summarize. What we have? We have got J1, we have got J2, we have got J3, we have got J4. So, these are the 4 matrices or the sub matrices into delta theta vector into delta v vector, that is equal to delta p vector, and that is equal to delta q vector. So, this we are again reproducing it. Now, here we would be writing down their dimension. So, dimensions would be, so this is n minus 1 cross n minus 1, J2, what would be the J2 dimension? N minus 1 cross n minus n, it is n minus 1 cross n minus m. What is the dimension of J3? J3 is n minus m cross n minus 1. So, it is n minus m cross n minus 1, and this is n minus m cross n minus m. This has a dimension of n minus 1 cross 1. This has a dimension has got n minus m cross 1. Delta p has got a dimension of n minus 1 cross 1. Delta q has a dimension of n minus m cross 1. So, then therefore, this entire vector has got total dimension of 2n minus n minus 1 cross 1. This vector, this entire vector has got a dimension of 2n minus m minus 1 cross 1, and this matrix J1, J2, J3, J4 is called the Jacobian matrix, and the matrix J, we call it matrix J, it is J1, J2, J3, J4. This is a Jacobian matrix, and this has got a dimension of 2n minus m minus 1 cross 2n minus m minus 1. So, this is a square matrix. So, this is irrespective of the number of buses and number of generators in the system, this Jacobian matrix would always a square matrix. So, this is called Jacobian matrix. Now, this equation, this big equation, we do further write in a more succinct form as, we further concisely write as this big equation, this big matrix equation, Jacobian matrix J into correction vector delta x is equal to mismatch vector delta m. So, this is the Jacobian matrix. So, this is the Jacobian matrix. This is called the correction vector, and this is called the mismatch vector. And what is delta x? So, this vector is called delta x vector. So, this vector is called delta x vector. This vector is called mismatch vector, because this is the mismatch between the specified value and the calculated value. So, this vector denotes the mismatch between the specified value and the calculated value. So, this vector is called the mismatch vector. This vector is called the correction vector, because we are trying to correct, or rather we are trying to calculate the corrected value of, or rather the correction value of theta, which should be added to the initial guess such that we can reach the final solution, and this big matrix is called the Jacobian matrix. Now, in this equation, as we have said, we have already seen in our basic Newton-Raphson load flow, basic Newton-Raphson numerical method, as we have already seen, that to calculate delta x, we can calculate as delta x is equal to J inverse into delta m. So, now how to calculate this J matrix? Now, this J matrix would be evaluated at, we note that this J matrix would be evaluated at the present known value of vector theta and vector v. So, this would be calculated, evaluated at the present known value of vector theta and vector v. Now, when we start the iteration, what is the known value of vector theta and vector v? This is nothing but the initial guess. So, then therefore, when we start the iteration, we know what is the vector theta naught, and we also know what is the vector v naught. Basically, those are nothing but the initial guess. So, when we know that, so then we do simply evaluate this matrix J at by substituting these values of theta naught and v naught. Now, the point is now if we have to evaluate this matrix J, that means we have to find out the each and every of this partial derivative. So, then how do we really evaluate this matrix J? So, that means we have to evaluate each and every of this matrix J1, J2, J3 and J4. So, then what we will do? We will simply first find out that what is the, or rather what are the analytical expressions of all these partial derivatives, as well as all these partial derivatives, as well as for all the partial derivatives of this matrices J3 and J4. And then in those matrices we would be simply substituting the values of theta naught and v naught, and after we do substitute the values of theta naught and v naught in these partial derivatives, we would be able to find out the numerical values of these matrices, or rather these sub matrices J1, J2, J3 and J4, and once we know the numerical values of this matrices J1, J2, J3 and J4, we would be able to find out what is the matrix J, and subsequently we can take the inverse. So, then therefore, our next task would be to find out what are the analytical expressions of all these partial derivatives, because until unless we know these analytical expressions of all these partial derivatives, we would not be able to find out the numerical value. So, our next task is to find out the analytical expressions of all elements of J1, J2, J3, J4. Now we start with J1. So J1 has got, so it is a square matrix, so it has got some diagonal elements and some non-diagonal elements. So these diagonal elements are, so if we look at these diagonal elements, these diagonal elements are nothing but delta P2 by del theta 2, del P3 by del theta 3 dot 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 del Pn by del theta n, and the off diagonal elements are del Pi by del theta k, where I is not equal to k. So therefore it has got J1 has got, it is a square matrix. So diagonal elements are del Pi by del theta I, and off diagonals elements are del Pi by del theta k, where I is not equal to k. So now you have to find out these expressions. Now to find out this expression, you have to write down the expression of Pi what do we do is, we simply take the ith term separately. Now here you see, when k is varying from 1 to n, at some instant or rather at some step k would be equal to I. So then we would be taking that term k is equal to I mean separately. So now what we have, so when actually k is equal to I, so then this becomes Vi into Vi squared, this becomes Yii cos theta I minus cos theta I. So then basically these two cancels out, and it only remains cos minus alpha I. Cos minus alpha I is nothing but cos alpha II. So then what we have got, Vi square Yii cos alpha II. So then what I have got is Vi square Yii cos alpha II plus k is equal to 1 to n not equal to I, Vi Vk Yik cosine of theta I minus theta k minus. Now what we have is, for now we write it as Vi square, we will just explain it, Gii. Now what is Gi, we just explain. So k is equal to 1 to n not equal to I, Vi Vk Yik cos theta I minus theta k minus alpha ik. Now here we have defined a term, or we have introduced a term Gii. So now let us explain what is Gii. Now what I have got, Yik is the complex element of the Y bus matrix corresponding to ith row and kth column. So it is given by magnitude Yik and angle alpha ik. So this can be written as Yik cos alpha ik plus j, that is j is the j is nothing but the complex operator. So this real part we call as Gik, and this imaginary part we call as Bik. So, Gii is nothing but the real part of the diagonal element Yii, and Bii would be similarly the imaginary part of the diagonal element Yii. So, then what we have? So, we have here, so Pi is equal to this. So, now we have to evaluate, now with this expression we have to evaluate now delta Pi theta I and delta Pi theta k. So, we start with the easier one. So, we first do this off diagonal terms, because that is the easier one. What the off diagonal terms? Off diagonal terms are delta Pi by delta theta k. So, what would be this? Delta Pi by delta theta k. What would be this? It would be simply, there would be only one term, because here there is absolutely no term as theta k. So, then therefore, this term would be 0, or rather basically the partial derivative of this first term would be 0, and among this term there is only one term which will come into picture. So, then therefore, what we will have is, we will have it is Vi Vk Yik sin theta I minus theta k minus alpha I k. To illustrate this, take an example. To illustrate this, take as an example, say n is equal to 5, and we are trying to find out, let us say del P3 by del theta 4, we are trying to find out. So, now from this expression, what is the expression of P3? P3 would be V3 square G33 plus k is equal to 1 to 5 naught is equal to 3 V3 Vk Y3k cosine theta 3 minus theta k minus alpha 3 k. So, if I just expand it, what I get? I get V3 square G33 plus V3 V1 Y31 cos theta 3 minus theta 1 minus alpha 31 plus V3 V2 Y32 cos theta 3 minus theta 2 minus alpha 32 plus V3 V4 Y34 cos theta 3 minus theta 4 minus alpha 34 plus V3 V5 Y35 cos theta 3 minus theta 5 minus alpha 35. So, this would be the complete expression of P3. Now, if I wish to take del P3 by del P4, so del P3 by del P4 del theta 4, from this, in this expression there is no theta 4, so then it will be 0. In this expression also there is no theta 4, so then therefore, this partial derivative would be 0, it also would be 0, it also would be 0, only this term would come into picture, and cosine has got a partial derivative minus, and for this minus theta 4 I will get another minus. So, then clubbing everything together I will get this. So, it would be V3 V4 Y34 sin theta 3 minus theta 4 minus alpha 34, and that is what we have written. So, delta Pi by delta theta k would be Vi Vk Yik sin theta I minus theta k minus alpha I k. Let us look into the diagonal terms. This diagonal term is delta Pi by delta theta I. Now, if we look at this expression, in this entire expression, only in the first term, in this term there is no theta I. So, then therefore, the partial derivative of this term with respect to theta would be 0, but in all the other terms this quantity theta I exists. So, then therefore, there will be partial derivative, and cosine has got an derivative of minus sign. So, then it would be simply similar. For example, as an example here, when you are writing down the expression of P 3, only in the first term there is no theta 3, but in all the other terms there is theta 3 available. So, then therefore, if we do delta P 3 by delta theta 3, so all these terms will contribute to this partial derivative, and all of them would be put together, and all this cosine will have minus. So, then therefore, putting them together, what we will have is delta P I by delta theta I is equal to minus k is equal to 1 to n not is equal to I V I V k y I k sin theta I minus theta k minus alpha I k. So, this is the expression of the diagonal term, and this is the expression of the off diagonal terms. So, when we find out this diagonal term and off diagonal terms for all of them, so then therefore, we are able to find out the analytical expressions of all the elements of J1. Now, for J2 and J3 matrices, these are nothing but rectangular matrix. So, then therefore, for these two matrices there is nothing called a diagonal term or off diagonal term, but for our own parlance, for J2 and J3, J2 and J3 which are rectangular matrices, we call something called self term, this is in our parlance, and we call we are abusing this term mutual, but just for the sake of this course we call the mutual term. Self term, for example, it would be in the case of J2 it would be delta Pi by delta Vi, and the mutual term would be delta Pi by delta Vk, where k is not equal to I. Self term means when this expression of Pi is being evaluated with respect to the voltage at its own bus, and mutual term is that when the expression of Pi is being evaluated with respect, or rather when the partial derivative of the expression of Pi is taken with respect to the voltage of some other bus. So, this is for J2. And for J3, this term should be, for J3 this term should be delta Qi by delta theta I, and it would be delta Qi by delta theta k, for k not equal to I. So, this is for J3. So, in the next classes we will be looking into these expressions, that what would be these expressions, and also we will be looking into the expressions of all the elements of J4. For J4, because it is an diagonal for J4 because it is a square matrix, so then therefore there would be a diagonal diagonal and off diagonal terms, diagonal and off diagonal terms. So, for J2 we would be looking at the self term as well as mutual term, that what would be the expression. For J3 also we would be looking at the self term and the mutual term, what would be the expressions, and for J4 also we would be looking at the expressions of diagonal and off diagonal terms. So, this we will do in the next lecture. Thank you.